Hey, how's it going? Let's check out some of these Java programs that I just did. Very simple Java class object stuff. So this is just some very basic stuff to get started. So here's our question. Create a class called vehicle. The class should have two fields, number of seats, number of wheels. And then the program is going to create two objects, motorcycle and car, of the vehicle class, and the output should show the descriptions. So we start by creating our class vehicle, initialize the attributes, number of seats, number of wheels, and then we create a two-argument constructor where we take two integers, seats and wheels, and then we assign it to the object, number of seats, number of wheels. Very simple. Displays value of attributes. Okay, so this is a member function of the vehicle class, and it returns a string, and as you can see it returns a string, and this function just puts together this string, number of seats equals, and then it interpolates number of seats, number of wheels, and then it displays the number of wheels for the current object on which this function is called. We get into our public static void main. Okay, this is our main program. So here you can see we create two objects. Vehicle motorcycle equals new vehicle, and then we pass it one seat, two wheels. Same thing for car, vehicle, car, and then we use the new keyword to create a new vehicle object, and then we give it 5 seats, 4 wheels. And then we need to output the description of the two objects. So we go system out, print line, object motorcycle, and then we call our motorcycle.display. And then we do the same thing with car. So as you can see here, it starts printing the line, and then it adds to this string whatever is returned from display. So let's take a look at that program. Very simple. We run it, and it gives us exactly what we expect. Let's go to question number 2. Create a class with a method. The method has to decide whether a given year is a leap year or not. So a year is considered a leap year if it has an extra day, 366 instead of 365. Right? That information doesn't really help us here because we're not going to make a program that counts all these days. So it occurs every 4 years. For example, 2008, 2012 are leap years. Okay, there's another condition. For every 100 years, a special rule applies. (1900) is not a leap year, but 2000 is a leap year. In those cases, we need to check whether it is divisible by 400 or not. So we'll get back to that in 1 second. Okay, let's go to our main program here and just look at how we're going to do this. We're going to create an array of integers called years, and we're going to give it some specific data. We're going to give it 1900 and 2000 because we want our function to return not a leap year and then leap year. And then we're going to give it a number of consecutive years, and what we should see is not leap year until we get to 2004, and then not leap year until we get to 2008, and then it should continue with not leap years. So we just iterate through that array for each year in years. We're going to print out this line, the year, and then we interpolate year is a, and then we check if leap year, year. So we go back to our static string check if leap year function. It takes an int as a year. We call it y over here. So this is a ternary statement. And if we look, it has this, blah, 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 or blah, blah, blah. So we can call that if condition 1 is true, or if condition 2 is true, it should return the string leap. Otherwise, it should return non-leap. So we have 2 conditions being checked, well, more like 3, I guess. We'll take a look at this ternary statement. So the first one is checking if the year is divisible by 4, and if it's not divisible by 100. Okay, we do 4, year modulus 4 equals 0, so we're checking if there's a remainder, right? So this first condition is checking for years like 2008 or 2012, where it's going to be divisible by 4, or it's going to return 0 if you modulus 4. But then it shouldn't return a 0 if you year modulus 100. So that means it's a year like 2008 and not a year like 2000. So the years like 2000 and 1900 and 1800, those are the ones we want to check if they're divisible by 400 or not. So we have another or. This is the second condition. So if we have a year like 1900, 1900 modulus 4 is going to give us 0, telling us it's a leap year. Modulus 100 is going to give us 0, telling us that it's a year that is a century, 1900, 2000. And then the last condition, if it's going to be if year modulus 400 also equals 0. So if we get a year like 1900, it should be modulus 4 equals 0, modulus 100 equals 0, and modulus 400 should also equal 0. If modulus 400 does not equal 0, so if it's like a year 1900, it's going to go back to non-leap. However, if it's a year like 2000, it's going to pass this final hurdle and it will return leap. Now some people might say it's better to use a series of if statements, but I found that it's kind of the same, saying if this, so if year modulus 4 equals 0, inside that if you nest another if year modulus 100 equals 0, and then you go year modulus 400 equals 0, and then you have, you know, it should return leap or non-leap from there. But then outside of that if, you return to the grandfather if, where you originally said year modulus 4 equals 0, but it didn't pass the second one where year modulus 100 equals 0, and then you return leap from there. I wanted to make it simple, you know. This is the way I chose to do it. It looks good to me. I understand it's kind of confusing, but on either side of these pipes, you have something explicit. it checks for this, it checks for that, or it checks for this, it checks for that. You know, in a way, I'm probably doing more operations than I need to, but that's something, you know, we can debate. I just thought it was kind of cool to do it this way because it just returns leap or non-leap. And it works, and it's simple, and it's a one-liner, but there's different ways you could probably do it. All right, let's try this one. And what is our output? $1900 is a non-leap year. 2000 is a leap year. 2001, non-leap year, non-leap, non-leap, and then we get to 2004, leap year. Non-leap, and then we get to 2008, it's another leap year. So that tells us it is working. Let's go to question number 3. Create a class with a method to calculate the factorial of a number. So the way you get a factorial of a number, let's say you have number 4. 4 times 3 times 2 times 1. Okay, and same with 5, same with 10. With 10, you're going to go 10 times 9 times blah, 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 all the way down. So that's going to be very easy to do with a for loop. Okay, so let's start at our main function here. So we start with an array of ints called numbers, and we're going to feed it some numbers. Now, we have to be careful here because an int can only contain a value of a certain size. Once you get past the maximum that an int can hold, you're going to get overflow. So, and I ran this program earlier, it overflows at 20, probably overflows earlier than that. So you might want to select an int type that holds a bigger number, like a long int would be in C or C++, but I'm still learning Java right now, and we're going to keep it simple, just with a basic int. So we're going to keep these numbers small to avoid that overflow. And we can keep that in our minds for the future if we want to update this program to handle bigger numbers and to be able to output a bigger number. But I digress. Let's look at this for loop here. For each n in numbers, and then just like our other programs, we're going to print out a line that says factorial n is, and then we're going to run our function here. Calculate factorial. So we have static int calculate factorial. It takes a number, just like how here we pass it a number. Now we're going to start with the factorial. We're going to initialize it as 1. As you can see here, we're going to return it so that it can be printed out in the string. But we're going to start with 1 because in our formula, we're going to go factorial is equal to factorial times I. Right? And we're going to start I at 1. So we look at our for loop. int I equals 1, while I is less than or equal to the number that we're given, and then we increment I. So we start factorial equals 1 times 1. It increments I to 2, it goes factorial equals 1 times 2. 2 times 3 times 4 until we get to our until it reaches until I is equal to number, right? Then we're just going to return the factorial. Very simple. Let's give it a shot. Okay, so I know the factorial of 4 is 24. So I put in the number 4, and we got 24 back. Okay, I happen to know that the factorial of 5 is 120 because I calculated it out by hand just to make sure. Sure enough, we get back 120. And just for fun, you can see how quickly this gets out of hand. Number 10 gets us 3,628,800. And 15, we're already up to a number that is hard to read. So we have thousands, millions, billions. 2,4,310,016. So we know that's very close to the ceiling, the maximum value that can be represented by an int. So if we're going to do factorials with a number bigger than 20, it looks like we're going to need to output a different type of integer. But for now, our program works, right? It's this part that matters. And let's say, yeah, you know, this int is another one we have to look at, because what if the number we get here is bigger than what int can represent? Well, if that's the case, we're going to have a factorial that is, you know, gargantuan. So we're talking about a program that is going to have to do some more complicated mathematics. So, things to consider about our program: it has some limitations because we're using an int here, but otherwise it works, and it can be refactored to do more at a later date. All right, so in summary, we had a look at 3 programs. We created a class with 2 attributes. It had a class function, so the objects we created were able to display their attributes. Number of different ways we could have done this as well. This was just very simple. We also did a program where we created a class with a method. And it was, again, very simple. The class just had the method and then the main function. And question 3, we just did a very simple function to calculate factorials, and we discussed some interesting consequences about the types that we use to represent these numbers. And we have a big limitation here with the factorial that we can represent using an int. Okay, thanks for watching. I hope that helps anyone who's doing some basic Java and might want to do a few simple programs like this. Peace.